So at this point, you should have done part one, the multiple choice, and known where you're at right now with regard to how many questions you have correct. Remember, you need 14 questions to get a 65. We want to aim for higher than that. So when I looked at all the questions that we've covered from Unit 1, Unit 2, and Unit 3, you would technically be able to get an 86% on this Regents just by knowing things from Unit 1, 2, and 3. Okay. Question number 25, even though well, this is not a math question, but even though we didn't specifically cover this, when you read it, it says minimizes bias. So there's actually a little formula for this, right? The more random something is, the less bias it has, right? So what's a way to make this as random as possible? So we could pick random names. And again, you're going to have to excuse my handwriting. Pick random names. You could do it from like a list. You can spin a wheel from a list of all the students, right? So everyone has a fair chance of getting chosen. And then you can ask each student their method, right? So again, if you remember this right here and say something about as random as possible, you'd be good with this question, okay? Question 26, so this is Unit 1, Lesson 2. So the first thing we want to do is to get the weird thing by itself. Specifically, the weird thing here is the square root. So since it's already by itself, you don't have to move anything over. How do you get rid of a square root? By squaring. Whatever you do to the right or to the left, you have to do to the right. So now that allows us to take the square root and the square, cancel each other out. So you're left with 3x plus 7 is equal to x minus 1 squared. What does it mean to square something? It means to multiply it by itself. So I'm going to have x minus 1, and you do need to do this algebraically for the full points. We're going to distribute here and get x squared minus 2x plus 1. If you don't know how to do that, you could do box method as well. So x minus 1 and x minus 1. So do that. These will add up together, and you're going to get x squared minus 2x plus 1. And that's equal to 3x plus 7. Okay. So now we want to move everything over to one side. So minus 3x minus 3x minus 7 minus 7. So when we do that, we zero it out. Okay, so we get 0 is equal to x squared minus 5x minus 6. And now we have to look for two numbers that add to be negative 5 and multiply to be negative 6. I usually show you to put it into the x. So two numbers that multiply to give me negative 6 and have to add to be negative 5. Okay, so what are they? So 2 times 3 gives me 6, and they add to give me 5. But I'm looking for two things that multiply to give me a negative number. So that means that the signs have to be different. So I'm going to have 6 and 1. Since the negative sign is with the 5, that means the 6, the bigger number, has to go with that. So let's check this, what we have right now. 1 times negative 6 is negative 6, and 1 plus negative 6 is negative 5. So that works out. So I have x plus 1 and x minus 6. I have to set them both equal to 0. So switch the sign. X plus 1 equals 0. Minus 1 minus 1. So I get x equals negative 1 is one of my answers. And I have x minus 6 is equal to 0. Add 6 to both sides and you get x is equal to 6 is my other answer. However, you have to check this. Okay. So literally I'm going to write the word check. And how do I check it? The easiest way is to go to the calculator, plug it into y equals, and then there's two things you can do at this point. Second graph allows you to go to the table, and we're looking across from negative 1. So across from negative 1, do I have the same answers on y1 and y2? I do not. So that means that this answer does not work. So x equals negative 1 does not work, does not work. And you can show some work here by showing that you know across from negative 1, here's our y1, here's our y2. So across from -1, I have 2 and -2, and these are not the same, not equal. And now let's check x equals 6. So across from 6, there's a 5 and 5, so x equals 6 does work, right? X equals 6 does work. We could even get happy about it and put like an exclamation point. And why? Because across from 6, under the y1 and the y2, the numbers are the same. And in this case, across from 6, there is a 5 and a 5. They are equal, okay? All right, so that will give you full points. If you did not know how to do it algebraically, you could have plugged it into the calculator and gotten x equals 6 as well. Um, and then you would just lose 1 point for this, right? So this is out of 2 points. If you just put an answer down, that's 1 out of 2. Listen, a 1 out of 2 is better than a 0 out of 2, okay? Let's try to get as many points as we can. So for the next one, we have to decide whether the population is increasing or decreasing. The easiest way to do that is to plug it into y equals and see if the graph is going up or if it's going down. So let's see. So the E, okay, I put the 37 in. The E is, you see where the on button is? Above that is the store. Best key ever for the multiple choice. Above that is LN. And right in blue above that is an E. So hit second and the LN button, and then you get E to the, and then we're going to put 0.0532. Instead of the T, let's go ahead and put the X, and then we're going to go ahead and we can hit graph at this point. And so now we wait and we see, okay, so the calculator's thinking right now, and it doesn't give us anything, which means that we have to change our window, or you can zoom out. So let's go ahead and zoom. Option number 3 is out, so we could just press number 3 and hit enter. And so now I can see the graph, right? And so I should be able to be like, hey, this function is from left to right, it is increasing. So you literally have to write the word increasing, right? And then if you say because the graph shows the function is going up from, that's a from left to right. And again, please forgive my handwriting, but okay. Good, that was 27. Number 28, the polynomial has a factor of x minus 3. Oh, I'm sorry, real quick. You could also say, if you wanted to, you could say because, let's do this one right here. We could say also because the e to the 0.0532, because this number is greater than 1, that's also why it's increasing. You could say either one of those answers. Just wanted to make sure that I was clear about that. Okay, so for this one right here, it says it has a factor of x minus 3. So what does that mean? The factor means that the remainder is equal to 0. Okay, that's what that means. So that means that if I were to take my function and put in, like if I do x minus 3 and set it equal to 0, to get what x is, you just add 3 to both sides, so you get x equals 3. So g of 3, since it's a factor, that means that g of 3 is equal to 0. Does that make sense? So g of 3 is 0, this right here is going to equal 0. So I have 0 equals, and then if I have x squared, so my x here is 3, x equals 3, right? I wrote it here and I wrote it here. I don't want to circle it, but you get the point. So wherever I see an x here, I'm going to plug in the number 3. So 3 to the third power plus, I don't know what a is, but I know that my x is 3 minus 5 times 3 plus 6. So I'm looking for a here. So this is minus 15 plus 6 here. 3 to the second power is 9a, and then this is 27. So this is all equal to 0. So when I solve this right here, I get 9a, right? And then this is going to be plus right? 27 minus 15 plus 6 is going to give me 18. So I set this side equal to 0. Subtract 18 from both sides. You know how to do this. You should be able to handle this right now. So 9a equals negative 18. Divide both sides by 9, and I get a equals negative 2. Okay. And how did I know that? Because it says it's a factor, which means that if I flip this sign, the negative 3, and make it positive 3, like this, and I plug in my x equals 3 wherever I see an x, right? Wherever I see an x, that'll allow me to get the a by itself because the factor means that this answer here is 0. Okay. Okay, so question number 29. This is, if you literally just found the pattern here is dividing by 3. If you literally found that, you would get 1 point out of 2. Hey, listen, I'll take a point over nothing. Recursive is from Algebra 1, so I'm going to put like an A1 right here. And what that means is you have to rewrite it using like a rule. So one thing you could do is you could say, okay, A1 is equal to, the first term is 189. So let's write that down. And then what is happening to that, right? Our rule is going to be to get AN, which is the term that we're looking for. You take this, you see how this right here is divide by 3? You take the AN minus 1, which represents the previous term, and you divide it by 3. So notation that you need to know, AN is your current term. The AN minus 1 is your previous term. And this is just extra. AN plus 1 is your next term. Okay. So if you have a cheat sheet, which you should at this point, or some sort of notebook where you write the stuff down that you need to know, that's all you need to do. Okay. All right, solve algebraically. So if you didn't solve it algebraically, you disobeyed, and you put this under y1, y2, and you got your answer, which is x is about 4.112 to the nearest thousandths. Then you would get 1 point, okay? And again, I keep saying this, 1 point is better than 0 points. Those points add up, okay? But let's just say you're like, hey, how do I do this algebraically so I get my full points? Let's do it. So we want to get the weird thing by itself again, which is RE. We have to get rid of the 2 by dividing both sides by 2. So that cancels out. So I get e to the 0.049x is equal to 15 divided by 2, which is 7.5. Okay. How do you get rid of e and e? Remember? So here's our calculator, right? E is under ln. See that button? So what we do is we ln both sides. Ln the left, ln the right. As soon as we do that, our ln and e cancel each other out. So what am I left with? 0.049x is equal to ln of 7.5. How do I get the x by itself? Divide both sides by 0.049. Divide by 0.049. This cancels out, and I'm left with x equals. Now, I could have left it like this if it didn't tell me to round it to the nearest thousandths. So I take my calculator, because it is telling me to round to the nearest thousandths, so I put my alpha y equals. Option number 1 allows me to get this fraction, right? So then I go to my calculator, press ln, which is above store. Again, store you definitely need to know for this Regents, and then on the bottom is 0.049. Hit enter, and you're going to get our answer. What did I do wrong? 0.049, right? Yes, good. Oh, I keep putting 0.049. It's not. It's 0.49. All right, so the 0 is not there, the 0 is not there, the 0 is not there. Yes. So when I go to my calculator now and I go up here, hit enter, and I take out my 0, which is not supposed to be there, hit answer, I'll get my 4.112. So x is about 4.112 is my answer for this question. Okay. If you want to put the little about symbol, squiggly line, feel free. Okay. All right. So it's defined, write the expression in simplest form. So whenever we have 4 terms, we're going to split the top, the numerator, we're going to split it down the middle. And so we have 2x to the third plus x squared with a line, and then we have negative 18x minus 9. and we basically have to simplify this. So factor the left, factor the right. Okay, so here what's common is an x squared. So what's left over is a 2x plus 1. Over here in the parentheses, I also have to have a 2x plus 1. So to get that, I multiply this by -9. So what's common here, right? If I take a look, I have a 2x plus 1 and a 2x plus 1. So I'm going to take that and I'm going to factor it out and write it out in front. And then if the 2x plus 1 goes away, I'm left with a x squared. The 2x plus 1 goes away, I'm left with a -9. Okay, so it says put it in simplest form, so this can be broken down a little bit further. So the 2x plus 1 stays. The x squared minus 9 can be broken down into x plus 3 and x minus 3. So what is the whole top? The whole top is a long expression, 2x plus 1, and on x plus 3 and x minus 3. Okay, now I have to go to the bottom right here, and I have to factor as well. So I have an x, but that's common. What is left over? 3 minus x. All right, so now I have to look and see what can be canceled out or simplified, right? Simplest form. So I see the x's. There's no x by itself, so I can't get rid of that x. However, let me get my red pen out. This x minus 3 and this 3 minus x, they are the same thing except flipped. So when I divide this, right, let me just write this down, x minus 3 and a 3 minus x. If you were to substitute any number in for x, you'll see that this answer gives you -1. Like, for example, 8 minus 3 is 5, and 3 minus 8 is -5. 5 divided by -5 is -1. So that means that when I cancel these out, I'm going to have a -1 there. So what's my final answer for this question? It's going to equal 2x plus 1 on the top. There's also an x plus 3. And then on the bottom, there's just a x. And we cannot forget that there's this -1. So we could put the -1 here if we'd like. That answer is valid. If you didn't want to, you could put -2x plus 1, x plus 3 over x. That's another answer. If you wanted to, you could put 2x plus 1 times x plus 3 over x with the negative sign out in front. Any of those answers would work, and you'd be completely correct. All right, 32. We did not do anything like this. You can go ahead and skip it. I'm not worried about 32. Let's get full credit on all the ones that we can do, okay? And all the ones that we've been taught until this point. All right. So for the next one, Patricia creates a cubic. So cubic means that you have something like x to the third function with a leading coefficient of 1. The zeros are 2, 3, and -6. So as soon as I hear that, I'm going to go to where -6 is, somewhere around here, and I'm going to see that this is a point that the graph goes through. I'm going to go to where I think 2 is. This is 2, and this is 3 right next to it. Okay, so there are points along all of that right there. All right, those are the zeros. Then it says with a leading coefficient of 1. Okay, that's good to know. So what does that help me do, right? That helps me figure out what my 3 factors are. So if my zeros are 2, 3, and -6, if I'm going backwards and I'm looking at my functions, like the factors, I'm going to take the sign and I'm going to flip it. So the opposite of +2 is -2. The opposite of +3 is -3. The opposite of -6 is +6. So here is my function. P of x is equal to this function. Okay, so now I plugged it into my y equals, and this gives me something that I can graph. So I can hit graph right here. It's already kind of zoomed out, but I can see very clearly, right? So I have something that looks like, right? It goes through 6, -6, my bad. It comes down like this, touches +2, And then if I were to take my calculator and zoom back to standard, which is zoom 6, I can see really what's happening between 2 and 3. So there's 2, there's 3. Okay, so it goes something like this. Okay, and it says sketch, so I don't need to be very exact. If it said graph, I need to hit second graph, go to my table and actually graph those points. Okay, but since it says sketch, I can leave it like this, and as long as my points are generally going through -6, 2, and 3, I should be in good shape. All right, that wasn't bad at all. Probability question, we didn't really get to that, so unless you remember something from Algebra 1, let's skip that for now. This says algebraically determine, so again, you don't have to. You could, to get 1 point out of 4 here, you could take this and plug it in. You do need to do that step algebraically, and then you can go to your calculator and put in this under y1, this under y2, and see where they meet, okay? But I want to get my full 4 points, and I'm going to go ahead and do this in the calculator, all right? So just like I said before, this is what y equals, so I'm going to take it and plug it in or substitute it there. So the x minus 2 squared stays, then I have a plus sign. Instead of my y, right, I'm plugging in negative 2x plus 7, and this whole thing gets subtracted 3, right? And this is getting squared. So all I'm doing is I'm following the rest of this right here, and it's getting set equal to 20. All right, so I can immediately combine like terms because that irks my soul. So I have negative 2x plus 7 minus 3 is 4. And I'm going to square this plus x minus 2 squared. So none of this is difficult. It's just very annoying. So I have x minus 2 times x minus 2 plus, and I have 2x plus 4. Again, it's squared, so minus 2x plus 4. And this set this whole thing equal to 20. All right, and again, very annoying, but it's okay. Let's do this. So x times x, x squared. X times negative 2 is negative 2x. I do the same thing with the negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Okay, I'm going to do the same thing over here. Negative 2x times negative 2x is positive 4x squared. Negative 2x times 4 is negative 8x. 4 times negative 2x is another negative 8x. And 4 times 4 is 16. Okay. All right. And then I set this whole thing equal to 20. All right. So now I'm going to combine some like terms here. So I have a x squared, negative 2x is negative 4x plus 4. I have a 4x squared here. Negative 8x is negative 16x plus 16. And this is equal to 20. Again, I'm going to combine some like terms here. Let's go here. So negative 4x, negative 16 can combine. And then I have the 4 that can combine with the 16. So let's do that. So we have x squared minus 20x plus 4x. Oh, 4x squared can combine with this 4x, well, this x squared here. So that's going to be 5x squared. And then 4 plus 16 is 20. And set this equal to 20. Okay. Now let's zero this out. Subtract 0, subtract 20, subtract 20. Cancels out, cancels out. Beautiful. So 5x squared minus 20x, that's a weird x, is equal to 0. Beautiful. What's common here, right? 5x. So write down what's left. X minus 4 equals 0. Set each of these equal to 0. So 5x equals 0. X minus 4 equals 0. Divide both sides by 5, and I get x is equal to 0. Okay, so that's one of my answers. Over here, add 4, or switch the sign, and I get x equals 4. Okay, so now I look back at my question. Do I just have x's, or do I have x's and y's? And I have x's and y's. So now that I found my x's, I can plug that in. I would plug it into the second equation, y equals negative 2x plus 7. So y equals negative 2 times x, which is 0. Let's get plugged in here. That's a minus 7, right? Plus 7. Okay, good thing I looked. So this is going to be, right, negative, anything times 0 is 0 plus 7. So y equals 7 is going to be my pair for this x. And then I do the same thing here, right? Y equals negative 2 times 4, right? I'm plugging this in here, plus 7. So that's negative 8 plus 7, and I get y is equal to negative 1, okay? So that's the pair. So here's my final answer, 0, comma 7, right? And the final answer for the second coordinate is 4, comma negative 1. So there's my final answer, and I'm done, 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 done. All right, 36. So we have two functions, p of x and f of x. So if you take a look at it, p of x, population of the palm tree, that one is decreasing at an annual rate of 3% per year. So let's talk about that, okay? So p of x is equal to, so if it's decreasing, right, we have, remember, let me take a little commercial break real quick. So our A is, what am I writing? Stop being lazy, Varghese. So I have A is equal to P, parentheses 1 plus or minus R to the T. Remember that formula? If we don't remember it, let's remember it now. And then there's nothing that's getting compounded, so I don't need to put the N here and the N here. That can be like a 1. So what's my P stands for my initial amount. So the palm tree starts at 500 palm trees. So I'm going to put my starting amount here. Since it's decreasing, it's going to be 1 minus at a rate of 3%. So 3% is the same thing as 0.03. So I do minus 0.03. And this is raised to the t power, or to the, in this case, since we're using x, let's just put x here. So there's my function, 500 parentheses 1 minus 0.03 times x. If I wanted to simplify this, I could write 500 is times 0.97, right? A dollar minus 3 cents is 97 cents to the x, and that's what p of x is, okay? So there's my p of x function. For my flamingos are growing continuously. So whenever you see continuous, that formula is a pert, P-E to the R-T. Remember when we did our finance, this is our best unit ever, so we want to get this right, okay? So our flamingos, f of x, are growing continuously. So our starting amount, our P, is going to be 200 flamingos. So I'm going to put, oh, I put the equal sign. We're starting out with 200, that's our P. It's always going to be e to the, what's our R? The rate is 2%, which is 0.02, and I'm going to put an X there. All right. So it says state the solution. It doesn't tell us to do this algebraically. Beautiful. Calculator. So just so you know, I always reset my calculator just to make it easier so I don't have to sit there and clear anything or adjust anything. So I type both of them, the functions in, my p of x and my f of x, and I'm going to go to my graph, and you should be able to see that I may see nothing here because the numbers are very big, right? 500, 200. So I'm going to need to do a little bit of zooming, okay? So I'm going to hit zoom whenever it finishes loading. Whenever you finish loading. Okay, stop it. Okay, why is this still going? All right, here we go. All right, so I'm going to zoom out, which is option number 3. And I'm going to just hit enter. And my calculator knows to zoom out. So, still thinking. Come on. You could do it. You could do it. You might need to zoom out some more if it's not doing anything. Okay, it's not doing nothing. So let's go ahead and hit the window. Okay, that's why, because we're only going to 40. Come on, calculator. Let's change our window. Let's be smart about this. So I'm going to go to my Y max, and since 500 is bigger than 400, I'm just going to go to 500 right here. And let's see if that does anything. Do I see anything now? Or do I need to go, hiya, hiya? Okay, look at me thinking with my noggin. So that's my first graph, the 500 parentheses 0.97x. Okay, look. So now I have both of them, right? So my calculator found the intersection, so I'm looking to see where they are equal. So to do that, I hit second trace. Option number 5 is intersect. Since I only have one point of intersection, I'm going to just try to hit enter, enter, enter. My calculator feels like it. Yeah, there we go. So I have 18, right? Because I'm rounding it to the nearest year. So my year is 18. And then it says interpret the meaning, right? So basically that means that the number of palm trees and flamingos will be equal in about 18 years. Done. Okay, good. There's 36. Finito. All right. This graph. This is the last question. Okay, so this question is worth 6 points. We haven't really covered this, but I'm gonna show it to you now anyway. Okay, I'm just gonna show it to you. No biggie. If you get it, you get it. If you don't, oh well. So I just zoomed in, okay, because I want to talk to you. I want to talk to you. So I'm also going to change my color. So the first thing is I see a graph. This graph is literally wavy, right? It's like doo doo, doo doo, doo doo, and then it's going to repeat, okay? Just so you know. Anyway, let me erase that. So what I want to do first is I want to find what did I just do? I'm finding the middle of my graph, okay? So this is called the midline. And so the midline. So this, I want to find out what number this is. So this is 2000, this is 3000. So let's see what is it going up by, right? That's not going up by 1. That looks like it's going up maybe by 200, then 400, then 600, then 800, and then 1000. Okay, so I figured out what it's going up by. Okay, so all of that to say, this number right here, the midline, is going to be at 2400. Okay, so I have to look over at my letters that I have here. I have an A, a B, and a C. Okay, so the C, this is my C, the number that I just found, my midline, is 2400, and that is my C. And again, unless I tell it to you, you're not going to know, but I'm telling it to you now. Okay, and again, like I said, you're going to pick up what you can. In IB Math, we do go into this as well, so we'll spend a little bit more time. And for those of you that are doing second semester of Algebra 2, you'll also be able to get this. Anyway, let's move on, okay? So I have one letter out of my 3. Beautiful. Next thing I want to do is I want to find my A. My amplitude is my height. How much is this distance from here to here, right? So I just kind of counted already. This is, every line is going to be another 200. So this is 200 and this is 200. So what is my height, right? 200 plus 200 is 400. So that is my A. So I have a 400 here. And then I'm going to put the sign because they're telling me it's sign. Okay. The hardest thing to do is to figure out our B. Okay. So our A again is our midline. I'm just going to go ahead and do this slowly. I'm sorry, our C is our midline. Our A is our height. The A stands for amplitude. Okay. And then our B. So our B is this. Okay. A B is equal to, there's a formula. And so what we have to do is we have to figure out how long is it going to take. Let me just go ahead and erase this. How long is it going to take to make a full cycle? So you might wonder, what is a full cycle? A full cycle is, you see how I'm starting right here at this point? I want to see how long it takes for me to get back to that point after doing a full cycle. So this is half a cycle. I've gone up. Then I'm going to go down and I'm going to get back to that point right there. So how long did that take me? If I go down, that took me 5 seconds. Okay? Does that make sense? right? How long it took me to get back to my starting point. So it took me 5 seconds to get back to that point. Okay, this is only halfway because I only went up and then I have to go down to get back to that point. All right, so now that is my, it's called my frequency. My frequency is equal to 5. Okay, all right, so which is, so the 5 is how long it took. So now what is my B, right? The B is, there's a formula, 2 pi over my frequency right here, right, which is 5. So my, the number that goes right here is 2 pi over 5, and I have to put a t next to it, okay? And again, like I said, that is the hardest part. So this is how long it takes, how long it takes to make one full cycle. And the 2 pi goes on the top, right? So it's always 2 pi. All right, so now I have my equation for n of t. So n of t is equal to, okay? So that's my first part that's done. And like I said, if you get this, great. If you don't get it, oh. So now let's see, they want us to use the same graph and graph this function. Let's see if we learned anything, okay? So we're going to start first at our midline. Our midline is 3200. So this is, let me erase some stuff that I wrote, okay, just to kind of get a fresh start over here. Okay, so my midline is 3200. So here is my midline. Actually, let me go ahead and do this in a different color so you see that it's a different thing. Where should I go? Orange, sure. So 3200. So this right here is my midline. That's gonna split my graph in half. The other number that I got is I have 2000. So my highest point is going to be 2000. So the 2000 above what I have. So this is my function, right? This is where the midline is. So I'm going to go 2000 above it. Okay. So how do I do that? 3200, right? So I'm at 3200 plus 2000 is 5200. So this right here is where my highest point is going to be. Okay. All right. And then my lowest point is going to be from 3200, I'm going to minus 2000. So when I do that, 3200 minus 2000 is going to be 1200. That's going to be my lowest point. So 5200 is my highest point and the 1200 is my lowest point. Okay. So now I'm going to see what I do to graph it. Okay. So I have my highest point and I have my lowest point, which is at 1200. All right. So I also realized, how do you know where you start or end, right? So I could just plug it into my calculator, right? So remember that when I just hit my, once I plug it in and I just hit graph, so the sign is above the comma under the apps button. So obviously I won't see anything, right? Because I want to make sure that my window is here, right? From 0, 0, the X max is going to be about 5.5, and my Y max is going to be about 6,000, okay? So let's go ahead and do that. I know I'm not going to see anything. I don't expect to see anything. So my X min is 0, 0, so I'm going to put 0 there. My X max, we just said, is 5 point, let's just go 2. We could even do 5.5 if we wanted. It's up to you. Why don't I just, yeah, leave it like that. And it's going up by ones, right? These are going up by ones. So, okay, so I have enough to help me graph. And then I'm going to do the same thing with the y's, right? So my y min is at 0, and I'm going up to 6,000. So let's put 0 here. My y max is going to be 6,000. And then my scale is, it's going up by 1,000. Right? You see this is going up by 1,000. Okay. Or you could even say it's going up by like 200. So I'll leave that up to you. Actually, why don't I do that? I'll just say, okay, instead of 1,000, I'm going to just put it's going up by 200 each. All right. So now I'm going to hit graph. Now I should be able to see it. Boom, boom. So now all I want to do is I want to do one full cycle, okay? So let's see if we remember this one right here. So we take our B, we dealt with the height and we dealt with the midline. What we didn't talk about is our B here. So it's 2 pi over, right? Our B is pi, and this cancels out, which means that our period is 2. Our period is equal to 2. So we're going to go over here and say that at 2, this is where our graph is going to end. So I can go ahead right now and go to my table, second table, and I can see across from, hold on real quick. Yeah. So across from 0, there's 3200. So I'm going to go to 3200. I'm going to put my dot right here. Okay. And then across from 1, there's also 3200. And across from 2, there's also 3200. Okay. So what is my function actually looking right? So what I'm doing is I'm going to go up to that 5200, right? So 5200 is right here and halfway in between. So it's going to go up to that 5200 and then it's going to come down to 1200. So 1200 is over here. So it's going to go through that 3200. It's going to come down to 1200 here. And then it's going to come back up to 3200. How do I know to stop? It says graph at least one cycle. I've graphed one cycle there and I'm done. Okay. So what I want to do is I want to label this as E of t. So this function that I just drew is E of t. Okay. All right. So that's my function. I've just graphed it. And then the last question says, how many times during the 5-second interval did they intersect? Do they touch each other? Are they equal to each other? So all I'm doing here is I have to do some counting here. So if I take a look at the one cycle that I've graphed, right? Let me do this in bright red, right? They hit once, they hit twice, but my cycle's not over, right? I'm going to keep going. So I want to know in the whole 5 seconds, how many times did they touch, right? So what's happening here is this is going to go back up again, come down, and hit again, right? So it's going to hit another 2 times here. So that's 4 times altogether, and then this is going to go up. And I mean, the second cycle and the third cycle are horrible, but it basically what you're doing is you're continuing the pattern, and you'll see that it hits 4 times. Okay, so there are 4 times that N of t is equal to E of t. They're not even asking you where they meet, they're just asking you how many times. And that's question number 37. We're done. Okay. Woo. Again, that last question, not worried about it. If you get it, great. If not, no biggie. But this was our Algebra 2 Regents for June 2023. Thank you.